Hello, in this lecture we'll answer two questions. In the first question we'll find out the value of line segment X with an inside rectangle ABCD. In the second question we'll find out the area of the green shape that is inside a semicircle. So we'll start with the first question. In the drawing we have rectangle ABCD. Inside rectangle ABCD we have a circle, and we know that the tangent from point A to this circle equals to 33 units in its length. The tangent from point B to this circle equals to 85 units in its length. The tangent from point C to this circle, it is the tangent that we are looking for, so we have to find out the value of x, that is the length of the tangent from point C to this circle. And finally the tangent from point D to this circle equals to 35 units in its length. And we have to find out the value of x, that is the tangent from point C to this circle. Okay, so first of all we define the center of this circle as O. We define the point of tendency of the tangent from point A to this circle as E. We will define the point of tangency of the tangent from point D to this circle as F. We will define the point of tendency of the tangent from point C to this circle as T. And finally, we will define the point of tendency of the tangent from point D to this circle as M. We will join points O and E together by a straight line. Point O is the center of the circle, point E is the point of the circle itself, therefore OE is the radius of this circle that we will define as R. And we have here all number 2, all number 1. According to all number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have tangent AB to this circle. Tangent AB is tangent to this circle at point M. Point M is the point of tendency. And we have the radius OM that is drawn to the point of tendency. And whenever a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. That is to say, if AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to this rule, rule number 1. So we actually can implement rule number 1 in our drawing. Well, because in our drawing we have the radius OE that is drawn to the point of tendency. Therefore, tangent AE will be perpendicular to OE. That is to say, this angle will be equal to 90 degrees according to rule number 1. Likewise, we will join points O and F together by a straight line. Again, point O is the center of the circle, point F is the point of the circle itself, therefore OF is the radius of this circle that is equal to R. And we have the radius OF that is drawn to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees. Likewise, we join points O and T together by a straight line. Point O is the center of the circle, point T is the point of the circle itself, therefore OT is the radius of the circle that is equal to R. We have the radius OT that is drawn to the point of tendency, therefore according to rule number 1, this angle equals to 90 degrees. Likewise, we join points O and M together by a straight line. Again, point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of the circle that is equal to R. We have the radius OM that is drawn to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees. In the next step, we will join points O and A together by a straight line. When joining points A and O, we created here the right triangle, triangle AOE. The right green triangle, triangle AOE. So we'll implement the Pythagoras theorem on the right green triangle, triangle AOE. The right green triangle, triangle AOE. Here by PT is the relation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AO squared equals to OE squared plus AE squared. Repeat again, according to the Pythagoras theorem and the right green triangle AOE, AO squared equals to OE squared plus AE squared. So AO squared equals to OE squared. OE equals to R, therefore OE squared is R squared plus AE squared. AE equals to 33 units according to what is given as the equation, therefore AE squared is 33 squared. So in conclusion, we found out that according to equation number 1, AO squared equals to R squared plus 33 squared. In the next step, we'll join points O and B together by a straight line. So here we will implement the Pythagoras theorem on the right yellow triangle OFB. On the right yellow triangle, triangle OFB. By PT. BO squared equals to OF squared plus FB squared. Repeat again, according to the Pythagoras theorem in the right yellow triangle OFB, BO squared equals to OF squared plus FB squared. So BO squared equals to OF squared. OF equals to R, therefore OF squared is R squared plus FB squared. FB equals to 85 units according to what is given as the equation, therefore FB squared is 85 squared. So in conclusion, we found out that according to equation number 2, BO squared equals to R squared plus 85 squared. In the next step, we join points C and O together by a straight line. And we implement the Pythagoras theorem on the right orange triangle, triangle OTC. So in the right orange triangle OTC by PT, we get that CO squared equals to OT squared plus TC squared. Repeat again, according to the Pythagoras theorem, in the right orange triangle OTC, CO squared equals to OT squared plus TC squared. So CO squared equals to OT squared. OT is R, so OT squared is R squared plus TC squared. TC is the line segment that we are looking for, so TC equals to X, therefore TC squared is X squared. So in conclusion, according to equation number 3, we found out that CO squared equals to R squared plus X squared. And finally, we join points D and O together by a straight line. So in this way we created the orange and the pink right triangle MOD. In the pink right triangle MOD, according to the Pythagoras theorem, DO squared equals to MO squared plus DM squared. Repeat again, according to the Pythagoras theorem, in the right pink triangle MOD, DO squared equals to MO squared plus DM squared. So DO squared equals to MO squared. MO is R, so MO squared is R squared plus DM squared. DM equals to 35, therefore DM squared is 35 squared. So in conclusion, we found out that according to equation number 4, DO squared equals to R squared plus 35 squared. In the next step, I will copy the 4 equations that we derived from the Pythagoras theorem in a new page. So here we have equation number 1. According to equation number 1, we found out surely that AO squared equals to R squared plus 33 squared. According to equation number 2, we found out that BO squared equals to R squared plus 85 squared. According to equation number 3, we found out that CO squared equals to R squared plus X squared. And finally, according to equation number 4, we found out that DO squared equals to R squared plus 35 squared. In the next step, I will copy rectangle ABCD with its circle inside it. In the new page, we'll analyze the rectangle with its circle. So we have rectangle ABCD. So this is rectangle ABCD with its circle inside it, that I copied from the original drawing. The center of the circle is at point O. We know that all the angles inside the rectangle are right angles, so those four angles are all right angles. This angle equals to 90 degrees. This angle, it is also equals to 90 degrees. This angle equals to 90 degrees. And finally this angle equals to 90 degrees. In the next step, from the center of this circle, that is to say from point O, we will draw perpendicular on AB. And we will extend the perpendicular towards DC. So here, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AB is T. Because of the fact that side AB is parallel to side DC in rectangle ABCD, it means that the perpendicular from point O to AB must be also perpendicular to DC. That is to say, this angle will be also equal to 90 degrees, and this angle will be also equal to 90 degrees. We define the touching point of the perpendicular from point O and DC as M. In the next step, from point O, we will draw perpendicular on BC. And we will extend the perpendicular from point O towards AD. Again, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BC as point N. Again, because of the fact that side BC is parallel to side AD in rectangle ABCD, it means that the perpendicular from point O to BC must be also perpendicular to AD. That is to say, this angle will be also equal to 90 degrees, and this angle will be also equal to 90 degrees. We define the touching point of the perpendicular from point O and AD as H. So inside quadrilateral ATHO, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the side of the fourth angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees, because 90 degrees plus 270 degrees is 360 degrees. It is the sum of the angles in any quadrilateral. So inside quadrilateral ATHO we have 4 right angles, therefore quadrilateral ATHO is a rectangle. Inside we have in quadrilateral HODM. Inside quadrilateral HODM we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees, and therefore quadrilateral HODM is a rectangle. Inside quadrilateral TBON we have 1, 2, 3 right angles, 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees, and therefore quadrilateral TBON is a rectangle. And finally, inside quadrilateral ONCM we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees, and therefore quadrilateral ONMC is a rectangle. So inside the big rectangle ABCD we have 4 small rectangles. Okay, we'll define side AH as H1, we'll define side HD as H2, we'll define side AT as B1, and we'll define side TB as B2. We'll join points A and O together by a straight line, and we'll implement the Pythagoras theorem on the right green triangle, triangle ATO. According to the Pythagoras theorem on the right green triangle, triangle ATO, AO square equals to, before we will continue here, we know that the opposite sides of a rectangle are equal to each other. So in rectangle ATHO, the opposite sides are equal to each other. We know that AH equals to H1, therefore TO must be also equal to H1. Likewise, AT must be equal to HO in rectangle ATHO, but we know that AT equals to B1, therefore HO must be equal to B1. In rectangle HODM, HD equals to OM, but we know that HD equals to H2, therefore OM must be also equal to H2. Likewise, HO must be equal to DM, but we know that HO equals to B1, therefore DM must be also equal to B1. Likewise, in rectangle TBON, TB must be equal to ON, but we know that TB equals to B2, therefore ON must be also equal to B2. Likewise, TO must be equal to BN, but we know TO equals to H1, therefore BN must be also equal to H1. In rectangle ONMC, OM must be equal to NC, but we know that OM equals to H2, therefore NC must be also equal to H2. And finally, ON must be equal to MC in rectangle ONMC, but we know that ON equals to B2, therefore MC must be also equal to B2. Now we'll continue to implement the Pythagoras theorem on the right green triangle, triangle ATO. The right green triangle, triangle ATO, AO square equals to B1 square plus H1 square. Repeat again, in the right triangle, the right green triangle ATO, AO square equals to B1 square plus H1 square. Likewise, we join points B and O together by a straight line. And we'll implement the Pythagoras theorem on the right yellow triangle, triangle TOB. On the right yellow triangle, triangle TOB by Pythagoras theorem. We get that BO square equals to b2 square plus h1 square. Repeat again, in the right angle triangle TOB, according to the Pythagoras theorem, BO square equals to b2 square plus h1 square. We join points O and C together by a straight line. And we'll implement the Pythagoras theorem on the right orange triangle OCN. The right orange triangle OCN, according to the Pythagoras theorem, we get that CO square equals to B2 square plus H2 square. And repeat again, in the right orange triangle, we get that CO, according to the Pythagoras theorem, CO square equals to B2 square plus H2 square. Finally, we join points D and O together by a straight line. And we'll implement the Pythagoras theorem on the right pink triangle ODH. The right pink triangle ODH, according to the Pythagoras theorem, we get that DO square equals to B1 square plus H2 square. Repeat again, in the right pink triangle DOH, according to the Pythagoras theorem, DO square equals to B1 square plus H2 square. Okay, so actually we have two different equations for AO square. We have two different equations for BO square, we have two different equations for CO square, and we have two different equations for DO square. So, in the next step, we'll create 4 more equations. According to equation number 1 that we will create, AO square according to the first expression must be equal to AO square according to the second expression. So AO square according to the first expression equals to R square plus 33 square. And it must be equal to AO square according to the second expression, that is equal to B1 square plus H1 square. So we found out that according to equation number 1, R square plus 33 square equals to B1 square plus H1 square. Then we create equation number 2 that states that BO square according to equation number 1 must be equal to BO square according to equation number 2. BO square according to this equation number 1 equals to R square plus 85 square, and it must be equal to BO square according to equation number 2, that is B2 square plus H1 square. So according to equation number 2, we found out that R square plus 85 square equals to B2 square plus H1 square. Then we will create equation number 3 that states that CO square according to equation number 1 must be equal to CO square according to equation number 2. So CO square according to this equation number 1 equals to R square plus X square, and it must be equal to CO square according to this equation number 2, that is equal to P2 square plus H2 square. Repeat again according to equation number 3. We found out that r squared plus x squared equals to b2 squared plus h2 squared. And finally, we create equation number 4 that states that do squared according to equation number 1 must be equal to do squared according to equation number 2. So do squared according to equation number 1 is r squared plus 35 squared, and must be equal to do squared according to this equation, that is b1 squared plus h2 squared. So I found out that r squared plus 35 squared equals to b1 squared plus h2 squared. So here we have 4 new equations. In the next step, we will subtract equation number 1 from equation number 2. So it is 2 minus 1. In this way, we create equation number 5. So according to equation number 5, here in equation number 2 we have r squared plus 85 squared minus equation number 1 we have here r squared plus 33 squared. In the other side of equation number 2 we have b2 squared plus h1 squared minus equation number 1 we have here minus b1 squared plus h1 squared. In the next step we will open the brackets of this equation number 5, and we get it according to equation number 5 r squared plus 85 squared minus r squared minus 33 squared equals to b2 squared plus h1 squared minus b1 squared minus h1 squared. So in this side of equation number 5 we have r squared minus r squared, that is 0. So r squared will get cancelled. In the other side of equation number 5 we have h1 squared minus h1 squared, that is also 0. So h1 squared will also get cancelled. So what is left from equation number 5 after we cancel those two expressions? In this side of equation number 5 we left only with 85 squared minus 33 squared. In the other side of equation number 5 we left only with b2 squared minus b1 squared. I repeat again, according to equation number 5, we found out that 85 squared minus 33 squared equals to b2 squared minus b1 squared. In the next step, we create equation number 6. That is to say, we subtract equation number 3 from equation number 4. So it is 4 minus 3. 4 minus 3. This way we create equation number 6. So here, in this side of equation number 4 we have r squared plus 35 squared minus equation number 3. In this side of equation number 3 we have r minus r squared plus x squared, and it is equal to, in this side of equation number 4 we have b1 squared plus h2 squared minus equation number 3 we have here minus b2 squared plus h2 squared. In the next step we will open the brackets of this equation number 6, and we get that according to equation number 6 we have r squared plus 35 squared minus r squared minus x squared, that is equal to b1 squared plus h2 squared minus b2 squared minus h2 squared. So in this side of equation number 6 we have r squared minus r squared, that is 0, so r squared gets cancelled. In the other side of equation number 6 we have h2 squared minus h2 squared, that is also 0, so h2 squared also gets cancelled. So what is left from equation number 6 after we cancel those two expressions? In this side of equation number 6 we left only with 35 squared minus x squared, that is equal to b1 squared minus b2 squared. So in the next step we will multiply this equation number 6 by minus 1, and we get that according to this equation number 6, minus x squared times minus 1 is plus x squared, 35 squared times minus 1 is minus 35 squared, that is equal to minus b2 squared times minus 1 is plus b2 squared, b1 squared times minus 1 is minus b1 squared. So in conclusion, we found out that according to this equation number 6, x squared minus 35 squared equals to b2 squared minus b1 squared. While according to equation number 5, we already found out that 85 squared minus 33 squared equals to b2 squared minus b1 squared. In the next step, we will create equation number 7 that states that b2 squared minus b1 squared according to equation number 5 must be equal to b2 squared minus b1 squared according to equation number 6. Okay, so here we have equation number 7, according to equation number 7, b2 squared minus b1 squared according to equation number 5 is 85 squared minus 33 squared, and it must be equal to b2 squared minus b1 squared according to equation number 6, that is actually x squared minus 35 squared. Again, equation number 7 states that b2 squared minus b1 squared according to equation number 5 must be equal to b2 squared minus b1 squared according to equation number 6. So according to equation number 7, we found out that 85 squared minus 33 squared equals to x squared minus 35 squared. Here we will add 35 squared to this equation number 7, and we get that according to equation number 7, 85 squared plus 35 squared minus 33 squared equals to x squared. 85 squared is 7,225 plus 35 squared is 1,225 minus 33 squared is minus 1,089, that is equal to x squared. 7,225 plus 1,225 equals to 8,450 minus 1,089 equals to x squared. So here 8,450 minus 1,089 equals to 7,361, that is equal to x squared. So according to equation number 7, we found out that x squared equals to 7,361. Here we take out all of this equation number 7, and we get that according to equation number 7, x equals to plus minus the square root of 7,361. So here we have two solutions that are possible for x, the positive square root of 7,361 and the negative square root of 7,361. But because of the fact that x is a length, x as a length must be a positive number, so we take into account only the positive solution. That is to say, here x will be equal to 85.796 units. So the answer to the question is that the value of the line segment that we are looking for, the value of x, equals to 85.796 units. We'll finish with the first question. In the next step, I'll present to you the second question, and we'll solve the second question in two different methods. In the drawing, we have a semicircle. We know that the diameter of this semicircle, AB equals to 6 units. Angle CAB equals to 30 degrees, and our mission is to find out the area of the green shape, the value of the area of the green shape. Okay. So here we will define the center of this circle as O, we will define the center of this semicircle as O. We know that the diameter of this semicircle equals to 6 units, therefore the radius must be equal to half of it. That is to say, the radius must be equal to 6 over 2, that is 3. That is to say, the radius OA equals to 3 units, and the radius OB must be also equals to 3 units. We join points O and C together by a straight line. Point O is the center of the semicircle, point C is the point of the semicircle itself, therefore OC is the radius of the semicircle, that is equal to 3 units. In triangle AOC, side AO equals to side OC. They are both equal to 3 units, therefore they are equal to each other. We have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees. So inside triangle AOC, 30 degrees plus 30 degrees is 60 degrees, so the missing angle here must be equal to 180 degrees. In order to complete the sum of the angles in this triangle to 180 degrees, this angle must be equal to 120 degrees. In the next step, I'll present to you how to find out the area of any sector. So here, if we have the sector A or B, that could be actually a sector is part of a circle. Okay. So this is sector A or B. That could be any sector. Sector OAB. AO equals to R, or B also equals to R. They are both the radii of the circle that contains this sector. Circle or semicircle that contains the sector. And the angle between the legs of the sector is theta. So, what is the area of this sector? First of all, the rounded side, the rounded line above OAB is the same for a sector. It means sector OAB. The area of this sector, sector OAB, will be equal to pi r square over theta times theta over 360 degrees. Pi r square is the area of the circle that contains the sector, and theta is the angle between the legs of the sector. So here the ratio theta over 60 degrees gives us the relative percentage that this sector occupy out of the area of the entire circle. Again, the ratio theta over 360 degrees gives us the relative percentage that this sector occupies out of the area of the entire circle. And then when we'll multiply that relative percentage by the area of the entire circle that is pi r square, we'll get exactly the area of this sector. Again, theta over 360 degrees is the relative percentage that this sector occupies out of the area of the entire circle, and then we will multiply the relative percentage by the area of the entire circle that is pi r square. We get exactly the area of this sector, sector OAB. Okay, so the area of sector AOB equals to pi r square times theta over 360 degrees. We use this formula in order to find out the area of sector AOC. So I copy sector AOC here in the new page, and we use the new formula in order to find out the area of this sector, sector AOC. So this is actually sector AOC that is covered from the original drawing. AO equals to 3, OC equals to 3. They are the semicircle that contains the sector, and they are also the legs of sector AOC. And the angle between the legs of sector AOC is 120 degrees. So theta equals to 120 degrees and R equals to 3. Therefore, we'll get that the area of this sector AOC will be equal to pi r square. R is 3, so pi r square is pi 3 square times theta is 120 degrees over 360 degrees. 3 square is 9, so in total this expression equals to 9 pi. 120 degrees over 360 degrees is 1/3. So in total this expression equals to 9 pi over 3. 9 over 3 is 3, so in total this expression equals to 3 pi. So we found out that the area of this sector AOC equals to 3 pi square units. Okay. In the next step, I will present to you a new formula for the area of any triangle, and we will use the new formula in order to find out the area of this triangle AOC. So here we have here triangle ABC that could be any triangle. This is triangle ABC. We know that the length of side AB of triangle ABC is A units, side AC equals to B units in its length, and the angle between side AB and side AC is theta. This is triangle ABC. So the area of this triangle ABC according to the new formula the area of triangle ABC equals to A times B times sinus theta over 2. I'll repeat again, the area of this triangle ABC that could be any triangle equals to A times B times sinus theta over 2. We use the new formula in order to find out the area of this triangle, triangle AOC. So I copy triangle AOC in this new page, and we will use the new formula in order to find out the area of this triangle. So actually, this is triangle AOC that they copied from the original drawing. AO equals to 3, OC equals to 3, and the angle between AO and OC is 120 degrees. So according to the new formula, the area of this triangle AOC, will be equal to AO times OC times sinus 120 degrees over 2. AO equals to 3, OC equals to 3, sinus 120 degrees is equal to 3 over 2, all divided by 2. 3 times 3 is 9, so in the numerator we have in total 9 times square root of 3 over 2 times 2 is 4. So in conclusion, we found out that the area of triangle, this triangle AOC, equals to 9 times square root of 3 over 4 square units. We have already found out that the area of sector AOC equals to 3 pi square units. But what is actually the area of the green shape? From the drawing, it is very easy to see that the area of the green shape equals to the area of sector AOC, minus the area of triangle AOC. Repeat again, the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. We have already found out that the area of sector AOC equals to 3 pi square units minus the area of triangle AOC. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. So in conclusion, we found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. Okay, so we finished with the first method. In the next step, I will present to you how to find out the area of this green shape according to the second method. So the area of the green shape according to the second method is equal to the area of the semicircle minus the area of triangle AOC minus the area of sector BOC. I'll repeat again, the area of the green shape according to the second method equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. So what is the area of the semicircle? The area of the semicircle is equal to the area of the circle over 2, that is to say it is equal to pi r square over 2. R, the area and the radius of the semicircle equals to 3. So it is pi times 3 square over 2. 3 square is 9, so in total in the numerator we have 9 pi over 2. So we found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out in the first method that the area of triangle AOC equals to 9 times 4 to 3 over 4 square units. The only thing that is left to find in order to find out the area of the green shape according to the second method is to find out the area of sector BOC. Okay. In order to find out the area of this sector BOC, we have to find out the angle between the legs of sector BOC. AB is the diameter of the semicircle, therefore AB it is absolutely a straight line. So if you focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of AB at point O? We have this angle that is equal to 120 degrees plus the missing angle. In total, they must be equal to 180 degrees. So the missing angle here must be equal to 60 degrees in order to complete the sum of the angles on the upper side of AB at point O to 180 degrees. This angle must be equal to 60 degrees. In the next step, I will copy sector COB in a new page and we use the new formula in order to find out the area of this sector COB. So actually, this is sector COB, the decommit from the original drawing. CO equals to OB, they are both the radii of the semicircle and they are also the legs of sector COB, and the angle between the legs of sector COB is 60 degrees, that is to say theta equals to 60 degrees. We have already found out that the area of any sector is equal to pi r squared times theta over 360 degrees. R is the radius of the circle of the semicircle that contains the sector. Theta is the angle between the legs of the sector, in this case is equals to 60 degrees. So the area of our sector COB, according to the new formula, will be equal to pi r square. R is 3, so pi r square is pi 3 square. Theta is 60 degrees over 360 degrees. 3 square is 9, so in total this expression equals to 9 pi. 60 degrees over 360 degrees, it is 1 over 6, so in total this expression equals to 9 pi over 6. Here we will divide both the numerator and the denominator by 3. 9 over 3 is 3, so in total in the numerator we have 3 pi. 6 over 3 is 2. So in conclusion we found out that the area of this sector COB is equal to 3 pi over 2 square units. Okay, now we'll find out the area of the green shape according to the second method. I will remind you that the area of the green shape according to the second method equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. I'll repeat again. According to the second method, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. We have already found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. And finally, we just right now found out that the area of sector COB equals to 3 pi over 2 square units. Here, 9 pi over 2 minus 3 pi over 2 equals to 6 pi over 2 minus 9 times square root of 3 over 4. 6 over 2 is 3, so in total this expression equals to 3 pi minus 9 times square root of 3 over 4 square units. So we found out that the area of the green shape according to the second method equals to either 3 pi minus 9 times square root of 3 over 4 square units, so in terms of numbers it is equal to 5.53 square units. We finished with the second method and the second question. In the next step I will summarize the lecture. We will start with the first question, of course. The drawing we have rectangle ABCD, inside rectangle ABCD we have a circle. The tangent from point A to the circle, that is to say AE equals to 33 units. The tangent from point B to this circle, that is to say BF equals to 85 units. And we are looking for the tangent from point C to this circle, that is to say CT, is equal to X. We have to find out the value of X. And finally, the tangent from point D to this circle, that is to say DM, equals to 35 units in its length. Again, we have to find out the value of line segment CT that is equal to X. So first of all, we define the center of this circle as O. So here, then radius OE it is drawn to the point of tendency, therefore according to rule number 1, this angle equals to 90 degrees. The radius OM also drawn to the point of tendency, according to rule number 1, this angle equals to 90 degrees. The radius OT it is drawn to the point of tendency, therefore this angle equals to 90 degrees. And finally, the radius OF it is also drawn to the point of tendency, therefore according to rule number 1, this angle equals to 90 degrees. Then we joined points A and O together by a straight line. In this way, we created the right green triangle AOE. According to the Pythagoras theorem, in the right green triangle AOE, AO square equals to OE square plus AE square. I repeat again. In the right green triangle AOE, AO square equals to OE square plus AE square. OE equals to R, AE equals to 33, therefore A O square equals to O E square. O is also O E square is R square. A is 33, therefore O E square is 33 square. So in conclusion, we found out that according to equation number 1, A O square equals to R square plus 33 square. Then we join points B and O together by straight line. We created in this way the right yellow triangle OFB. In the right yellow triangle OFB. BO square equals to OF square plus FB square. Repeat again. BO square equals to OF square plus FB square. OF equals to R, BF equals to 85, therefore BO square equals to OF, that is R, so OF square is R square. BF is 85, therefore BF square is 85 square. So in conclusion, we found out that according to equation number 2, BO square equals to R square plus 85 square. Then we join points C and O together by a straight line. In this way, we created the orange right triangle OTC according to the Pythagoras theorem. OC square equals to OT square plus CC square. Repeat again. In the orange right triangle OTC, CO square equals to OT square plus CC square. OT is R, TC is X, therefore CO square equals to OT square. OT is R, so OT square is R square. TC is X, so TC square is X square. So in conclusion, we found out that according to equation number 3, CO square equals to R square plus X square. Then we joined points D and O together by a straight line. In this way, we created the pink right triangle MOD. According to the Pythagoras theorem, in the pink right triangle, DO square equals to MO square plus MD square. Repeat again. DO square equals to MO square plus DM square. MO equals to R, MD equals to 35. Again, DO square equals to MO square. MO is R, so MO square is R square. The M is 35, therefore the M square is 35 square. So in conclusion, we found out that DO square equals to R square plus 35 square. Then I copied the 4 equations in a new page. Those are the 4 equations. And then I copied rectangle ABCD with circle inside here. Point O is the center of the circle. From point O, we go perpendicular on BC. Again, from point O, we go perpendicular on BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We extended the perpendicular from point O towards AD. Okay, here. Because of the fact that BC is parallel to AD in rectangle ABCD, it means that the perpendicular from point O to BC must be also perpendicular to AD. Again, because BC is parallel to AD, the perpendicular to BC must be also perpendicular to AD. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Then from point O, we go perpendicular on AB. Again, from point O, we go perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. Then we extended the perpendicular from point O towards DC. Because of the fact that side AB is parallel to side DC, it means that the perpendicular from point D to AB must be also perpendicular to DC. Again, because of the fact that AB is parallel to DC, it means that the perpendicular from point O to AB must be also perpendicular to DC. So this angle also equals to 90 degrees, and this angle also equals to 90 degrees. In quadrilateral AT edge O, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees plus the fourth angle. In total, they must be equal to 360 degrees. According to the rule, that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees. 1 equals 90 degrees plus 270 degrees. This is the sum of the angles of the other. The sum of the angles in the other 3 angles here is 270 degrees plus 90 degrees. It is 360 degrees. It is the sum of the angles in any quadrilateral. So this angle must be equal to 90 degrees. So inside quadrilateral AT edge O, we have 4 right angles, therefore quadrangle ATHO is a rectangle. Likewise, inside quadrangle edge ODM, we have 1, 2 right angles, therefore the fourth angle must be also equal to 90 degrees, and therefore quadrangle OHDM is a rectangle. Likewise, in quadrangle TBON, we have 1, 2 right angles. Therefore, the fourth angle must be also equal to 90 degrees, and therefore quadrangle TBON is a rectangle. And finally, in quadrangle ONMC, we have 1, 2 right angles, therefore the fourth angle must be also equal to 90 degrees, and therefore quadrangle ONMC is a rectangle. So inside the big rectangle ABCD, we have 4 small rectangles. Then we defined A edge as H1, HD as H2, AT as B1, and TB as B2. And we know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle ATHO, AT equals to HO. But we know that AT equals to B1, therefore HO must be also equal to B1. Likewise, AH equals to TO, but we know that AH equals to H1, therefore PO must be also equal to H1. Likewise, in rectangle HODM, HO equals to DM. We know that HO equals to B1, therefore DM must be also equal to B1. Likewise, HD must be equal to OM, but we know that HD equals to H2, therefore OM must be also equal to H2. Likewise, in rectangle TBON, the opposite sides are equal to each other. That is to say, DB must be equal to ON, but we know that TB equals to B2, therefore ON must be also equal to B2. Likewise, TO must be equal to BN, but we know that TO equals to H1, therefore BN must be also equal to H1. And finally, in rectangle ONMC, ON equals to MC, but we know that ON equals to B2, therefore MC must be also equal to B2. And finally, OM equals to NC, but we know that OM equals to H2, therefore NC must be also equal to H2. Then we join points A and O together by a straight line. In this way, we created the right green triangle ATO. We implemented the Pythagoras theorem on the right green triangle ATO. According to the Pythagoras theorem, AO square equals to B1 square plus H1 square. In the right green triangle ATO, AO square equals to B1 square plus H1 square. Then we created, we joined points B and O together by a straight line. In the right yellow triangle OTB, BO square equals to B2 square plus H1 square. Again, BO square equals to B2 square plus H1 square. Then we joined points O and C together by a straight line. So in the right orange triangle O and C, CO square equals to B2 square plus H2 square. In the right orange triangle, CO square equals to B square plus H2 square. And finally, we joined points D and O together by a straight line. According to the Pythagoras theorem, in the right green triangle ODH, DO square equals to B1 square plus H2 square. Again, DO square equals to B1 square plus H2 square. So we have here 2 different equations for AO square, we have 2 different equations for BO square, we have 2 different equations for CO square, and we have 2 different equations for DO square. Then we created another 4 equations. According to equation number 1, AO square, according to the first expression, must be equal to AO square according to the second expression. That is to say, R square plus 33 square equals to B1 square plus H1 square. Then we get the equation number 2 that states that BO square according to equation number 1 must be equal to BO square according to equation number 2. That is to say, R square plus 85 square equals to B2 square plus H2 square. Then we created equation number 3 that states that CO square according to equation number 1 must be equal to CO square according to equation number 2. That is to say, R square plus X square equals to B2 square plus H2 square. Finally, we created equation number 4 that says that DO square according to this equation number 1 must be equal to DO square according to this equation number 2. That is to say, R square plus 35 square equals to B1 square plus H2 square. So we have here 4 new equations. Then we subtracted equation number 1 from equation number 2. That is to say 2 minus 1. So in equation number 2 we have in this side half square plus 85 square, minus equation number 1 we have here half square plus 33 square. Minus half square plus 33 square. In the other side of equation number 2 we have b2 square plus h2 square, minus equation number 1 that we have here minus b1 square plus h1 square. Then we open the brackets of this equation, equation number 5. We found out that r square plus 85 square minus r square minus 33 square equals to b2 square plus h1 square minus b1 square minus h1 square. R square minus r square is 0, so r square will get cancelled. In the other side of equation number 5 we have h1 square minus h1 square, that is also 0. So h1 square also will get cancelled. So what is left from equation number 5 after we cancel those two expressions? In this side of equation number 5 we left only with 85 square minus 33 square. In the other side of equation number 5 we left only with b2 square minus b1 square. So according to equation number 5 we found out that 85 square minus 33 square equals to b2 square minus b1 square. Then we subtracted equation number 3 from equation number 4. That is to say 4 minus 3. So in equation number 4 we have r square plus 35 square minus equation number 3. In equation number 3 we have here r square plus x square. In the other side of equation number 4 we have b1 square plus h2 square minus equation number 3 we have here b2 minus b2 square plus h2 square. Then we open the brackets of this equation, equation number 6, and we found out that r square plus 33 square minus r square minus x square equals to b1 square plus h2 square minus b2 square minus h2 square. R square minus r square is 0, so r square will get cancelled. h2 square minus h2 square is 0, so h2 square will also get cancelled. What is left from equation number 6 after we cancel those two expressions? In this side of equation number 6 we have 35 square minus x square. In the other side of equation number 6 we have b1 square minus b2 square. We multiply this equation, equation number 6, by minus 1, and we have here minus x square times minus 1 is plus x square. 35 square times minus 1 is minus 35 square, and it is equal to minus b2 square times minus 1 is plus b2 square, and b1 square times minus 1 is minus b1 square. So in conclusion we found out that x square minus 35, according to equation number 6, x square minus 35 square equals to b1 square minus b1. X square minus 35 square equals to b2 square minus b1 square. And according to equation number 5, we have already found out that 85 square minus 33 square equals to b2 square minus b1 square. Then we get equation number 7 that states that b2 square minus b1 square according to this equation, equation number 5, must be equal to b2 square minus b1 square according to this equation, equation number 6. Again, according to equation number 7, b2 square minus b1 square according to equation number 5 must be equal to b2 square minus b1 square according to equation number 6. That is to say 85 square minus 33 square equals to x square minus 35 square. We added 35 square to this equation, equation number 7. We found out that 85 square plus 35 square minus 33 square equals to x square. 85 square is 7,225. 35 square is 1225 minus 33 square is 1089, that is equal to x square. 7,225 plus 1225 is 8,450 minus 1089 equals to x square. 8,450 minus 1089 is 7,361, that is equal to x square. So in conclusion, we found out that x square, according to equation number 7, x square equals to 7,361. We took the root out of this equation, equation number 7, and we found out that x equals to plus minus the square root of 7,361. So here we have two solutions that are possible for x. But because of the fact that x is a length, x as a length must be a positive number. So we'll take into account only the positive solution of x. Okay, that is to say x equals to 85.796 units. the line segment that we are looking for, x equals to 85.796 units. We finished with the first question, then I presented to you the second question, and we solved the second question in two different methods. In the drawing we have a semicircle, AB equals to 6 units, AB is the diameter of the semicircle that is equal to 6 units, angle CAB equals to 30 degrees. Our mission is to find out the area of the green shape. We define the center of this semicircle as O. The diameter equals to 6 units, therefore the radius must be equal to half of it, that is to say the radius must be equal to 6 over 2, that is 3. So that is to say the radius OA is 3 units. The radius OB it is also 3 units. We join points O and C together by a straight line. Point O is the center of the semicircle, point C is the point of the semicircle itself, therefore OC is the radius of the semicircle that is equal to 3 units. In triangle AOC, AO equals to OC. They are both equal to 3 units, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides we have those two angles. So those two angles that are located in front of equal sides must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees. So inside triangle AOC, those two angles are equal to 60 degrees. So 30 degrees plus 30 degrees is 60 degrees. In total, they equals to 60 degrees. So therefore, the missing angle here must be equal to 180 degrees. In order to complete the sum of the angles in this triangle to 180 degrees, this angle must be equal to 120 degrees. Then I presented to you how to find out the area of any sector. Sector is a part of a circle. So this is sector AOB. That could be any sector. Angle between the legs of sector AOB is theta. We have leg AO equals to leg OB. They are both equal to R. That is the radius of the circle that contains the sector. Okay. The area of this sector, sector AOB, that could be any sector, will be equal to pi r squared. That is the area of the circle that contains the sector times theta over 360 degrees. So I will explain the formula here. The ratio theta over 360 degrees gives us the relative percentage that this sector occupies out of the area of the entire circle. And then when we will multiply the relative percentage by the area of the entire circle, that is pi r squared, we will get exactly the area of this sector, sector AOB. Again, theta over 360 degrees, this ratio gives us the relative percentage that this sector occupies out of the area of the entire circle. And then when we will multiply this relative percentage by the area of the entire circle, that is to say pi r squared, we will get exactly the area of this sector, sector AOB. That is to say the area of sector AOB equals to pi r squared times theta over 360 degrees. We use this formula in order to find out the area of this sector, sector AOB. So I copy sector AOB here, and we use the new formula in order to find out the area of this sector. The angle between the legs of the sector is 120 degrees, that is to say theta equals to 120 degrees. R is 3 units. R is the radius of the circle that contains the, in this case is the radius of the semicircle, doesn't matter it. It could be also the radius of the circle that contains the sector. And OC and AO are also the legs of the sector. And the angle between the legs of the sector is 120 degrees. So theta equals to 120 degrees, R equals to 3. pi r squared is pi 3 squared. Theta is 120 degrees over 360 degrees. 3 squared is 9, so in total this expression equals to 9 pi. 120 degrees over 360 degrees is 1/3. So in total this expression will be equal to 9 pi over 3. 9 over 3 is 3, so in total this expression equals to 3 pi. So we found out that the area of sector AOC equals to 3 pi square units. In the next step I presented to you how to find out the area of any triangle by a new formula. Here we have triangle ABC that could be any triangle. We know that the length of side AB is A units, side AC equals to B units in this length, and the angle between side AB and side AC is theta. According to the new formula, the area of this triangle ABC that could be any triangle equals to A times B times sinus theta over 2. Again, the area of this triangle ABC equals to A times B times sinus theta over 2. We use the new formula in order to find out the area of this triangle AOC. So I copy triangle AOC here. This new present, we use the new formula in order to find out the area of this triangle. AO equals to 3, OC equals to 3, and the angle between the two sides AO and OC is 120 degrees. According to the new formula, the area of this triangle AOC will be equal to AO times OC times sinus 120 degrees over 2. Again, AO times OC times sinus 120 degrees over 2. AO is 3, CO is 3, sinus 120 degrees is equal to 3 over 2, all divided by 2. 3 times 3 is 9. So in total, in the numerator, we have 9 times root of 3. 2 times 2 is 4, so in the denominator, we have 4. In conclusion, we found out that the area of this triangle AOC equals to 9 times root of 3 over 4 square units. But we have already found out that the area of sector AOC equals to 3 pi square units. What is actually the area of this green shape? It's very easy to see from the drawing that the area of this green shape equals to the area of sector AOC minus the area of triangle AOC. Again, the area of sector AOC minus the area of triangle AOC will give us the area of this green shape. Okay. Again, the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. The area of sector AOC is 3 pi, the area of triangle AOC is 9 times root of 3 over 4. So we actually found out that the area of the green shape equals to 3 pi minus 9 times root of 3 over 4 square units. So in terms of numbers, it is equal to 5.53 square units. We finished with the first method, then I presented to you how to find out the area of this green shape according to the second method. According to the second method, the area of this green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector BOC. I repeat again, the area of the green shape according to the second method equals to the area of the semicircle minus the area of triangle AOC minus the area of sector BOC. The area of the semicircle is the area of the circle over 2. That is to say, it will be equal to pi r square over 2. Here R is the radius of the semicircle, that is equal to 3 units. So R equals to 3, therefore pi r square is pi 3 square over 2. 3 square is 9, so in total in the numerator we have 9 pi, so in total this expression equals to 9 pi over 2. So we found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out that the area of triangle AOC in the first method equals to 9 times root of 3 over 4 square units. So the only thing that is left to do in order to find out the area of the green shape according to the second method is to find out the area of sector BOC. In order to find out the area of this sector BOC, we have to find out the angle between the legs of sector BOC. AB as the diameter of the semicircle must be a straight line. So if we focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Which angles we have on the upper side of AB at point O? We have this angle that is equal to 120 degrees plus the missing angle. In total they must be equal to 180 degrees. Therefore the missing angle here must be equal to 60 degrees. In order to complete the sum of the angles on the upper side of AB at point O to 180 degrees, this angle must be equal to 60 degrees. Okay, so the angle between the legs of sector BOC is 60 degrees. So I copied sector BOC in the new page and use the new formula in order to find out the area of this sector, sector BOC. So this is sector BOC or COB that I copied from the original drawing. The angle between the legs of sector COB is 60 degrees. OC equals to OB, they are both the legs of sector COB, that's equal to 3 units, and they are also the radii of the semicircle that is also equals to 3 units. And we have already found out that the area of any sector equals to pi r squared times theta over 360 degrees. Theta is 60 degrees and r is 3. So pi r squared is pi 3 squared. Theta is 60 degrees, so it is 60 degrees over 360 degrees. 3 squared is 9, so in total this expression equals to 9 pi. 60 degrees over 360 degrees is 1 over 6. So in total this expression equals to 9 pi over 6. We divided both the numerator and the denominator of this expression by 3. 9 over 3 is 3, so in total in the numerator we have 3 pi. 6 over 3 is 2. So in conclusion we found out that the area of sector COB equals to 3 pi over 2 square units. Now we will find out the area of the green shape according to the second method. I remind you that the area of the green shape according to the second method will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. I repeat again, the area of the green shape according to the second method equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. We have already found out that the area of the semicircle equals to 9 pi over 2 square units minus the area of triangle AOC. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units, and finally we just right now found out that the area of sector COB equals to 3 pi over 2. 9 pi over 2 minus 3 pi over 2 equals to 6 pi over 2. 6 over 2 is 3, so in total this expression equals to 3 pi. Minus 9 times square root of 3 over 4. So in conclusion we found out that the area of the green shape according to the second method equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers it is equal to 5.53 square units. Okay, thank you very much.